What is up, guys? It's your boy Zach here, aka That Bio Dude, coming at you with the funniest, coolest, and most informative AP Bio videos on the interweb. And today I'll be talking about locomotion and support system. Alright, so skeletons are very diverse, so we'll start off with that. Skeletons serve as support system for animals, providing rigidity protection and surfaces for muscle attachments. Several different kinds of skeletons occur in the animal kingdom. Flatworms, roundworms, and annelids have hydrostatic skeleton. Mollusks, arthropods have exoskeleton composed of calcium carbonate or chitin. Sponges, echinoderms, and vertebrates possess endoskeleton, which is internal. This is what we have as humans. Alright, so here's a picture on top. We have a worm, which has a lizard talking about the locomotion, the earthworm. So the coelom is divided by septa, and each body segment is a separate locomotor unit. There are both circular and longitudinal muscles. As circular muscles contract, a few segments extend. The worm is held in place by septa, knee-like chitinous sutures on each segment of the body. Then, as longitudinal muscles contract, a portion of the body is brought forward. This series event occurs down the length of the worm. And you kind of see in the picture, as it's kind of moving along, it uses those muscle contractions. So like the dance move, the worm, just like that, if you know how to do that. I don't. And then the picture on the bottom, we have the insect, which has an exoskeleton. Exoskeletons support muscle contraction to prevent drying out. The chitinous exoskeleton of an arthropod is shed as the animal molts. Until the new skeleton dries and hardens, the animal is more vulnerable to predators, and muscle contractions may not translate into body movements. In this photo, a dog-day Circada tibicin has just finished molting. Okay, now endoskeletons. See, a lot of advantages about the endoskeleton. You can grow with the animal. It supports the weight of a large animal. Excuse me. It protects vital internal organs. It's protected by outer tissues, and it allows flexible movements. And so you can see the jointed vertebrae endoskeletons advantage listed. In addition, an endoskeleton lends itself to adaptation of the environment. Vertebrae move in various ways: jumping, flying, swimming, running. It allows for all these things to happen. Okay, the human skeleton system has many functions that contribute to homeostasis. The rigid skeleton supports the body. The skeleton protects vital internal organs. The skeleton provides sites for muscle attachments. The skeleton serves as an important storage reservoir for ions, and the skeleton produces blood cells. So long bones, we'll touch on those first. Most of the bones in the human skeleton are composed of cartilage during prenatal development. Because cartilaginous structures are shaped like future bones, they provide models of these bones. The cartilaginous models are converted to bones when calcium salts are deposited in the matrix by osteoblasts. Slowly the bone turns into spongy and compact bone, which completes the long bone. It's a combination of those two. And then the epiphyseal plate, or the growth plate, at the top of these bones are responsible for continued bone growth. And these can stay open to whatever age, usually, whatever, from obviously birth. As soon as the bones form, I shouldn't say birth, as soon as the bones are formed until, 18 or whatever, somewhere in there, then they'll close and then your bone growth is done. Okay, so here's a picture of a long bone. You see the long bone is encased by fibrous membrane, except where it's covered at the ends by the hyaline cartilage. Spongy bone located beneath the cartilage may contain red bone marrow. The central shaft contains yellow bone marrow and is bordered by compact bone, which is shown in the enlargement on the right. So you can kind of see here on the left, here you have the long bone right here. So you can see on the top you have that hyaline cartilage. You see that growth plate that I was talking about, which is right in there. Spongy bone, this is what's the top part of it. And then as you kind of break it down further, you see the compact bone. You have that medullary cavity in there, which contains yellow bone marrow. And then you have the periosteum, which is the kind of the inside, the outer layer of the bone. And then you can see here you kind of a blood vessel inside of there. And then breaking it down even further, the hyaline cartilage, you can see it's filled with a matrix, and inside that you have those chondrocytes and the lacunae. And then looking down just at the compact bone to see what's in there, you can see you have the osteons in the lacunae, and inside those you're going to have the central canal, and that's where you can find your blood vessels. Alright, so the axial skeleton lies in the midline of the body and consists of the skull, the vertebral column, thoracic cage, the sacrum, and the coccyx, totaling up to 80 bones. So you can kind of see here in this picture what kind of bones we're dealing with. You have the skull, which is the frontal bone, zygomatic bone, maximal, mandible, pectoral girdle, which is your clavicle and your scapula, thoracic cage, your sternum ribs, costal cartilages, pelvic girdle is your coxal bones, sacrum, coccyx, and then moving down, you get your patella, metatarsals, phalanges, and then clavicle, scapula, humerus, vertebral column, ulnar, radius, carpals, metacarpals, phalanges, femur, largest body in the bone, fibula and tibia work together to make your lower leg, and then your tarsals, of course, and your ankle. We're going to touch a little bit more on the skull. So breaking down the skull even further, you have, so first off, right away, you see these lines kind of right here. These are called sutures. They're like immovable joints that hold different pieces of the skull together. And so you have the parietal bone right here, the frontal bone, obviously in the front, temporal bone right here, occipital bone in the back. As you can kind of see, they kind of correlate with the lobes of the brain as well. Occipital bone covers the occipital lobe. And then you have the external auditory canal, that's your ear. Mandible, which is your chin. Maxilla, which is kind of one of your main face bones. You have your nasal bone. Temporal, and then you can see in the right side a different view of the same bones. You see the temporal bone on the side, stuff like that. All right, now you have the spinal curvature and the rib cage. So the spine is made up of the cervical curvature, thoracic curvature, lumbar curvature, and the pelvic curvature, which is the sacrum and the coccyx. And you can kind of see in the ABCD here, you have some disorders. So you have this B is scoliosis. It's an abnormal lateral sideways curvature. That, you don't want that. It doesn't look good. Kyphosis is an abnormal thoracic curvature, which is kind of going back. I don't think you want that either. It looks pretty painful. It kind of looks like a hunchback kind of deal going on. And then lordosis is an abnormal lumbar curvature, where the lumbar curvature isn't actually going to be curving in too much. That doesn't look healthy either. So, and then the rib cage. Rib cage consists of thoracic vertebrae, the 12 pairs of ribs, the costal cartilage, the sternum, and the breastbone. And you can see the sternum right down here, down the middle, which is actually broken down into 3 different bones: the manubrium, the body, and the xiphoid process. And then you have your 12, or what do you got? 7 true ribs. You have your 3 false ribs, and then 2 floating ribs. Okay, and appendicular skeleton consists of bones within the pectoral and pelvic girdles and the attached limbs. The pectoral shoulder girdle and above limbs are specialized for flexibility, but the pelvic girdle, hip bones, or lower limbs are specialized for strength. A total of 126 bones make up the appendicular skeleton. And taking a look at that, you have the clavicle, the head of the humerus, the scapula, the humerus, head of the radius, your radius, ulna, carpals, metacarpals, phalanges. You have your femur, your patella, your tibia, and your fibula. Tarsals, metatarsals, phalanges, all part of the appendicular skeleton. So joints. Bones are connected at the joints, which are classified as fibrous, cartilaginous, and synovial. Fibrous joints, such as sutures that exist between the cranial bones, are immovable. Cartilaginous joints, such as those between the vertebrae, are slightly movable. And then synovial joints are freely movable, but the 2 bones are separated by cavity. The ligaments composed of 5% of tissue hold the bones together. So your knee is an example of a synovial joint. You can kind of see here you have your quadriceps up top. I kind of work down the muscle in the bottom. You have the 2 bones that are meeting, the femur and the tibia. And you can see in there you have a lot of stuff going on. You have the joint cavity, the articular cartilage. You have those bursa sacs. And you have then, this is kind of like there's your patella right there. This is obviously your knee. Tendons help work together with that. There's fat in there, and this is kind of how synovial joint works. Those 2 immovable things, that immovable bones work together to move. Human muscular system. 3 types of muscle can be found in the human body. Today we're going to focus on the skeletal muscle, which is voluntary, is extremely important in maintaining posture, providing support, and allows movement. In addition, skeletal muscle is very important in homeostasis by helping maintain a constant body temperature. The contraction of skeletal muscle causes ATP breakdown, releasing heat that is distribution about the body. So that's the human muscular system on the right there. We're not going to go through them all, but obviously you're going to have a lot of different muscles in your body, for all the way from your legs all the way up to your face. All right, microscopic anatomy physiology. A vertebrate skeletal muscle is composed of a number of muscle fibers in bundles. Each muscle fiber is a cell containing the usual cellular comments, but some components have special features. A sarcolemma forms a T system. These T tubules penetrate into the cell so that they come into contact but not fuse. You have the sarcoplasmic reticulum, which are expanded portions of this modified endoplasmic reticulum, and then myofibrils are contractile portions of a muscle fiber. So taking a look at this, you can see here, up here on the left, says the muscle contains bundles of muscle fibers, and the muscle fiber has many myofibrils. So you can see that's a bundle of muscle fibers right there. Taking a look down even further, that's how small a myofibril is right there. So looking at a single muscle fiber, you're going to have that sarcolemma that covers the top and with a sarcoplasm between, and that's going to bundle up a bunch of different fibrils. Inside one myofibril, you're going to have that one sarcomere, and you can see that Z line to Z line right there. A myofibril has many sarcomeres. And then keep looking down even further. When the sarcomeres relax, you have that cross bridge of the myosin and actin working together to make the muscles work. And then the sarcomeres contract, and they're coming together. That's how your muscles work. It's all thanks to actin and myosin. And that's going to do it for this video. Thanks for watching on Locomotion and support systems. See you next time.